Hello, everyone. My name is Xin Chen from University of Nottingham, UK. I'm recording this video to demonstrate how to use the software we developed for interactive image segmentation, mainly for 2D and 3D medical images. The basic idea is based on the fully connected conditional random field, but there was a fast implementation developed by Stanford group a few years ago. We thought it's pretty cool to use it for our interactive segmentation purpose. And because we do a lot of medical image analysis, quite often task is to do the segmentation. We can either use the segmentation to train a machine learning, deep learning network to achieve automatic segmentation later, but it has to be based on very accurate segmentation in the first place. So we tried a few tools, other tools. They either use active contour or you need to draw a few dots along the lines, and also some techniques based on graph cut, which is similar to our method. But we find it's not very useful or user-friendly, and some of them are pretty slow. So we decided to design a software by ourselves, and we feel it's pretty easy to use. So we want other people also use it for free, basically. But the downside is developed in MATLAB, so you have to install the MATLAB runtime library when you install the file, which is pretty large. But there's no free launch anyway. So if you're interested, you can click the link below to download the software and have a try yourself. So in terms of how to use this software, we try to design the user interface as simple as possible. So we have all the buttons listed on the left-hand side, starting with loading the images and 2D and 3D, and also you can load the segmentation result. For simple pre-processing for the 3D volume, you can do this by clicking this button to convert the 3D volume into isotropic volume in terms of the millimeters, and you can have 2 millimeter, 1 millimeter, and 0.5 millimeter, and so on. So to have isotropic volume. For segmentation, normally you can play with 2 parameters, but we set it as some default settings. So we thought it's pretty a robust one to start with. So always good to try this default settings before you adjust these settings. Then there's a segmentation button. So if you after you annotate or labeling or your image, you need to press this button, so it will automatically do the segmentation based on your menu annotations. So this result refinement button is, if you're happy with your segmentation result, you can click this button. It will do a further refinement to fill in some holes and to smooth the meshes, the 3D segmentation result. So in this result section, it will display the measurement, the size of the volume in terms of the voxels or millimeter cubic, for each of the class. Currently, we designed the software to support up to 10 different foreground classes. So we thought it's pretty large enough to fit for most of the applications, but it can easily extend it to more than 10 labels if you want it. But we need to change the code a bit. And after you're happy with the segmentation result, you can save it by click the Save button. It supports Nifty file or MATLAB file. And then if you want to load new images, you can reset all, so it'll clean everything for you. And there's the Exit button, will deal with all the memory stuff. And it's always good to click this Exit button rather than click the top right corner, this close button here. And then here display the information, tell you whether it's doing the segmentation or the task is done. So all the information will be shown here. So also there's a simple instruction if you click the About button to tell you who we are, and if you may want to make a contact, this is the email, and also a very simple instructions to tell you how to use this. But to keep watching this video is much better than reading the instructions. Okay. So now we start with loading a 2D image. So if we click a 2D image, then go to maybe one of the demo images. So here I want to segment multiple organs within this 2D image. So always a good practice is to get the region of interest. So a lot of them are background pixels, so there's no sense to calculate them. So you can use this region cropping to crop the image and with just focus on the region of interest. Then now you can specify a few labels. This is the background label, which is white. So I don't care about those regions. So I can just do some randomly select some lines within the background. So then you can say, now I want the first foreground class, which is yellow, to be this organ here. Again, random lines. And for this guy, I want the green label. And also blue one to this one. And red one for the kidney. Just roughly cover the regions. Then if you're happy with labeling, click segmentation. I will run this within a few seconds. You should be able to get the first segmentation result. Because this is interactive, if you're not happy with this, you can always add labels. For example, you're not happy with this bit, which is a bit confusing. The background supposed to be background, but confused with the foreground class, which kind of makes sense because the intensity is quite close and edge is not very clear. So we can add a few background lines with here and maybe somewhere here because you're not happy with that, and maybe some, and say this is belongs to the ribs, it's not organ, and I can go to this side and also click this should also be the background. Okay, if you're happy with that, you can run again. It will be, the algorithm will consider all the previous annotations together to run another time. So you can see it's significantly improved the segmentation. It's pretty much guaranteed. Every time you add more lines, it will keep improving the result. Okay, so for example, if you're not happy with this red bit, you just simply add lines and here. And for the yellow bit, there are some holes. So the general idea, a brief idea, is basically the segmentation is based on two things. One is the intensity of all the selected pixels of different class, and also on the location of those labels. It will optimize the whole, treat this as a graph to optimize the segmentation result based on these two terms. So if you're happy with that, so it can already improved quite a lot. So, and also I'm not happy with this bottom bit, so I can add another line. So it's pretty much cleared everything and that I don't want. And maybe I will want make this bit perfect again, just add another line. So now it's pretty much perfect. So if I'm happy with that, and I'll do result refinement. So I'll giving you much better result, not much better, but slightly better, by refining, treating all the current labels as the true label. So we'll do some refinement, still using the CRF optimization. So now, if you're happy with this, and you can save it, but also you can see all the measurement is showing here. because for the 2D image, we don't have the actual physical units. So this measurement is actually based on pixels. So this is the total number of pixels for class 1, which is the yellow, and so on. So you can see all the result here. You need to write this result down if you want to have this measurement. When you save it, this will not be automatically saved. Okay, it will only save the image. But you can always load the images and to have these calculations later. So if you're happy with that, you can save it. Name it. You can use .mat, which is default MATLAB format, or you can use PNG, BMP, TIFF. Just don't use JPEG, okay? Because you lose some information if you use the JPEG. So you can do test TIFF and save. We can load the image later, or maybe do it now. So to load the result, you need to, of course, load the original image first, which to find out. So we load the original image. Remember, we cropped the image before, but don't worry, the segmentation result will save according to the original resolution and size of the image. So now, after loading the image, you can load the segmentation result, which is D called test. TIFF. Okay. You have a note here. So basically saying the segmentation result is only for visualization purpose. It is not valid for interactively improving the result. Basically saying that now if you are happy with certain part, if you only want to improve this part, if you add only, for example, yellow lines here to improve it, it will not improve based on this current segmentation. It will do the segmentation from scratch, simply because when we save the image, all the added lines or annotations were not saved. So we didn't design the way you can keep improving this result by loading result back. Okay, so you have to be happy with the segmentation before saving it. Okay, so but you can visualize it here. Okay, you can see it's pretty good, but people argue that for 2D image it's relatively simple and you can use a lot of other software to do it. There's no point using this one, but the benefit actually is to do a 3D image segmentation. We find is pretty useful, and I'll show you now. So for 3D image, we accept DICOM file or .mat, which is MATLAB format, and we're nifty. So if I select one of the nifty files, which if I go to data, which we are cared about a segment and endovascular ZAC, which is, I'll show you. So this particular DICOM file contains 151 slices, which is a CT. So if you, for 3D volume, if you go to the folder and simply click any one of the files, it will load the whole slices, all the slices within that folder. Also, it will check the segment orientations, and if you have multiple orientations, it will pop up a choice to select one of them. But I'm not sure it will compatible with all the DICOM format, but if you find any problem, you can feedback to us. We can always improve. So basically, it load up all the slices because it has a thicker slice, 3mm slice thickness, and which is much higher than the in-plan resolution, the pixel size. So that's why we designed this pre-processing. You can easily change it to isotropic volume by clicking this button to change it to 2mm or 1mm or even higher or lower. So if we stick with 2mm for faster computation for the moment, so and basically you have 4 axes, 4 places you can display pictures. The 1, 2, 3 showing the 3 different views, And the fourth one display the current the segmentation result. Because currently we don't have any segmentation result, so it's just showing the original image. So you can click these different buttons to visualize, look at the slides. Basically, what we want to segment as a demonstration is this ZAC here. I'll crop it. Again, we strongly recommend you do the region cropping first before you run the segmentation, because majority of the voxels are background. You don't care. If you only want to segment small region, you can do region cropping along 3 axes. But you only allow to crop this once for simply to make the software simple, basically. And but you don't need to crop all the 3 axes. You can pick 2 of them to crop it. Okay, so after cropping, if you're unhappy with the resolution, so you can always change to a higher resolution, for example, 1 millimeter. It will resample from the original image, so it won't lose the resolution. So for the demonstration purpose, if we just choose a lower resolution to have a quicker interactions to demonstrate this first. So now it's time to select the labels. You can do this from any or all of the axes. Okay, so let's start with this axis. So this is the background that I want to get rid of. And this bit is the ZAC. I want to segment this. And also I want to segment the vessels. Okay, some simple lines. Then you can do segmentation. Click the segmentation to see, because it will run on the full 3D. So although we only annotated 1 slice out of 50 along this direction, and also other directions where we didn't even segment, add annotations yet, but it will generate a 3D volume segmentation according to your current labels. Okay, so you can see for its JSON slices, it's already pretty good, but it's not perfect yet. Okay, but no worries, we can improve it. This is just visualize it from different views. Also, you can look at in 3D. Okay, so for the whole volume, I only annotated 1 slice. It's already giving me a pretty good shape of the 3D. I only need to clean up a bit on the different view. So if I select one of the view, which I'm not happy with, maybe this one. Okay, so now for this view, you can say, I want to annotate this view now. This is background, also a bit of background here. And background. And then the yellow class, and green. Okay, so I'm happy with this. And if I click segmentation again, so as a default, you will see this image display is not this one, because as a default, it will always display the slide, the result of the first axis. The image is in the first axis. But if you click the sliding bar, you can see the result of this slice. Anyway, okay. Okay, so you can. Well, I'm not happy with this slice. I can add a bit of lines here, saying this need to be cover a larger region, and the green background. Okay, I can do another segmentation. So you can see even for 3D volume, it works pretty quick because we are working on a relatively lower resolution. But compared with the graph cut-based method is also quick already. So we're pretty happy with the implementation. I'm not happy with this slides as well. If I do this, and also green segmentation. Okay, so it's much better. And also, I'm pretty sure it will improve its JSON slides. Okay, you can see it's pretty much there. Is the shape what is like what we wanted. This is the confusing bit of the adjacent organ, neighboring organ. So it's always good to have balancing out these different multiple classes. Don't just select the background. Okay, so it helps to have a better segmentation. Okay, so now we can press this toggle this radio button here to see how it looks in 3D. Maybe there's some cut bit due to these edges of the boundary, and I may crop it too hard in the first place. But if you're unhappy with this bit, which I'm not happy with this, and you can keep improving it until you're happy. And also you can, well, come back to these slides. Okay, so basically these two parameters, you can try to adjust this one. So the first one from local to global is control the smoothness of the curve of the object. Okay, if you make it towards global, it will make the curvature a bit more smoother, the mesh a bit smoother, but it is not helpful if you want to segment details gaps, like for example you have some leakings here. So but you can normally we already set it to be a very good default settings, so I would rather keep it back, but you have the options. And for example, like I said, it's a balancing between your labels and intensity. If you want it to be more intensity focused, to focus and segment more larger regions across the whole image, probably want to a bit towards more on the intensity side. And if you do the segmentation, okay, it will basically segment more regions outside this, and in terms they have a much similar intensities, more similar intensities according to the current label. But I would rather keep as its original settings. Okay. So, okay, assume we're happy with the mesh now. Of course, there is some redundant bit, but I think you're convinced now you can easily remove this by adding more background classes. Now, just want to demonstrate the result refinement. So you can have a smoother curve and also remove some of the background, but not all of them. We don't want to have a much more smooth curve when you click this refinement, because we don't want to change the segmentation too much. It's just based on the current label. If you're happy with, it will just do a final refinement based on the CRF. Okay. Again, for this result section, it will display the volume size in terms of millimeter square, millimeter cubic. If you have the loaded in DICOM, because we can load the voxel spacing from the header, so it's have the physical units. So it's all displayed here. You need to write it down if you care about this measurement, the volume. Again, you can save them into Nifty or .mat. Okay, so for MATLAB file, it will save both the original one and the label into a structured variable into this. For Nifty, it will save two separate files. I'll show you if I reset all. So if I load the Nifty of the original one, which I saved here, I believe it's called test. So it has two files. One is the original ones that after you do the isotropic resampling, and the other one is your segmentation result. You can load it again in my D drive. Okay, basically it says the segmentation result is only for visualization purpose. It is not valid for interactively improving the result. Basically what it says is because we didn't save, when we save the result, we didn't save all the annotation, manual annotations. So it cannot keep improving the result, okay? If you are happy with some of the segmentations, for example, you want to add some green part here, if you add them, it will consider only this bit were labeled currently, and it will run the segmentation from scratch, okay? So if you want to improve it, you need to redo it. So make sure before you save it, you need to be happy with the result you're saving. Okay. That's pretty much how to use it. Then I want to show you the benefit of having more labels and how powerful it is after you making the efforts to do this interactive segmentation. If I load another data, which is the MRI raised, which are currently working on, to one of them. So I believe it's B. So it only it has 25 files, but some of them are in different orientations. We need to choose one of them, which only contains like 10 or 11 slices. Okay, this is the raised. We care about segmenting the carbon bonds, which contains 8 small bonds in the center of this. But you can see the slice thickness is 3 millimeter again, so it's quite low resolution along this axis. First thing to do is to change this to isotropic because the resolution is too low and then you have some blurred um, image along this axis anyway. So, but what you want to do is to segment on these views, which is much better. So you know how to do it, but I don't want to do it, but I just want to show the result by loading it. I previously did. So data erased. Okay, same message again from previously, and you can see we use all the 10 labels for 10 different bonds. Okay, you can see the intensity is pretty close to each other within the bonds. And that's why we need these interactions to segment this. And I don't believe other software can do a decent job, and simply by clicking the points of 10 different classes, you can easily get lost when you go to different slides and you don't know which bond belongs to which bond. You can easily confused. But with our software, you can easily get this information and to interactively improve it by adding labels and to different slices and removing and different the wrong labels. And also you can see in 3D and how it looks in 3D. But it's pretty low resolution. When I segment it, I use the 0.5 millimeter. So if I change it to 0.5 millimeter, if I load it again, it should give me much better resolution, which is the original resolution I worked on. Just bear with me. So the data erased. So okay, so now if we see the 3D mesh again, so it's much better resolution now because this is half millimeter voxel space. Okay, you can see these represented by different color, and so for this segmentation, it took me 20 minutes and to segment it. I wouldn't say it's quick, but it's relatively intuitively robust and easy to use actually compared with other software. So give it a try if you need to generate some ground truth segmentation or for your project, and you can always send us emails. And if you have questions, and if you want us to improve certain things, I will appreciate your feedback. And here's all the information you needed. Okay, of course you can save the result later. Okay, thank you for watching, and welcome to download our software and use it. It is free, but you need to send me email, ask for password. Simply, I just want to keep a record who is using our software. Okay, thank you.